Entropy is a concept in physics that measures a system's ability to do work. It's also often described as a measure of disorder. These two definitions might sound like unrelated BS, but they ultimately mean the same thing. That's because the amount of work a system is able to do is very dependent on how ordered that system is in the first place. That's what Boltzmann's equation means, but as we know, equations are for suckers and nerds, so we're going to turn this into a sick example. Say, for instance, you have a nice square ice cube made of nice square lattices of oxygen and hydrogen. This ice cube system is very ordered. You can tell it's ordered because it has a lot of corners. This system has the capacity to do things, like melt. Once it melts, it becomes less ordered, it loses its corners, and the nice ordered lattices turn into a bunch of separate wiggly molecules. Now that it's less ordered, it doesn't have the capacity to do any more things. It can't become ice again unless an outside force does something to it, but the water doesn't contain the ability to do things inside itself anymore, like it did when it was a nice square block of ice. The disorder of this system has increased, and it can no longer do work. Its entropy has increased. If that's too many lattices for you, imagine you have an hourglass full of sand. At the moment the hourglass is flipped like this, we can say that the sand is relatively ordered, but in a slightly different way than the ice cube, because now it has a lot of gravitational potential energy. The sand is going to use all this potential energy to fall down to the bottom of the hourglass, but once it's fallen, it doesn't have the ability to get back up again. Even though the system contains the same amount of stuff, it's no longer ordered in a way that allows it to do anything without an outside influence. The system can now take on fewer forms. The disorder of this system has increased, and it can no longer do work. Its entropy has increased. In more edgy terms, one can describe entropy as a figurative sort of system decay. And if you want to be even more edgy than that, you need to know that
in all energy exchanges, if no energy enters or leaves an isolated system, the entropy of that system increases.
An isolated system is one that no energy or matter can enter or leave. That is to say, the amount of energy and matter in an isolated system stays constant, though the mass and energy can change forms. That's what E equals mc squared describes. Matter can become energy, like when something burns to create light and heat. Its mass decreases, but it releases energy. A pile of ash has higher entropy than a piece of wood, and so on. Equations also go both ways, so energy could, in theory, turn back into mass again, I guess, but this is real life, so we're not going to worry about that right now. You might be like, well, if the amount of energy in the system stays the same, then why is any of this relevant? You might say, what matters is having energy to do stuff, and we still have that. True, but it matters because the amount of usable energy decreases. You can't get all the sand from the bottom of the hourglass back up again unless you interfere with the system from the outside, and you can't burn what's already been burned unless you do some really fucked up shit. Even though there's still the same amount of overall stuff in each of these systems, they've lost their ability to use that stuff in any sort of meaningful way. They've become more entropic. The reason disorder increases in an isolated system is because some extra energy is always dissipated every time something happens, no matter what. When a star fuses hydrogen, it shoots out a lot of energy into the world in the form of heat and light. Some of that energy will be absorbed by nice plants to make nice plant food, and some of that energy will be absorbed by sentient gas beings to power their supercomputers that run solely on photons. But a lot of that energy from that star will just kind of dissipate into outer space, and it won't accomplish anything, kind of like posting on the internet. In the same way, when you, probably a human, eat a nice plant, you'll use the parts of it that don't go through your digestive system to make new cells for your body, to lift things, and to get good at League of Legends. But a lot of that plant-based energy will just be radiated off into the abyss as body heat, kind of like posting on the internet. None of the mechanisms at work here are perfectly efficient. There's always some energy lost. Similarly, when you're actually in the act of getting good at League, most of the energy you're expending goes into stuff like regulating your body heat and moving your withered arm muscles from position to position. None of this is very efficient either. Bits of usable energy are being dispersed into less ordered states by every action you take, all the time. By laying around in bed all day, you would lessen your own contribution to the world's entropy by an incredibly tiny, but still theoretically measurable amount. There are probably more valid ways to preserve usable energy, but please feel free to use this as justification for your own depressing life habits if you like. Finally, from bed, assume that the universe is an isolated system, like an hourglass. We can assume that this is true with some confidence because, as far as we know, the universe isn't taking any new matter or energy from anywhere else, nor is it losing any. It's not connected to any other universes, probably. That is to say, the amount of sand in the universe is constant. What we have is all we have. And because things are constantly being done in the universe, its entropy is constantly increasing. A system at maximum entropy has lost its ability to do work, in both the physics sense and, by extension, the colloquial sense. Though it still has energy, that energy is
dispersed, spread out, wasted, and useless.
So long as a system is both isolated and at maximum entropy, that system can never do any work, ever again. It has become null, and at the greatest extreme, nothing can ever happen there again. This is the fate of every isolated system, and in many trillions of years, this will be the fate of our universe. A uniform, entropic soup, extant, but incapable of any action. This is the heat death of the universe. Thank you.